Today we are going to learn about the von Neumann architecture. The von Neumann architecture is basically the technology that we use in our devices, such as our laptop. It is easier than the Harvard architecture, and it is very famous, and it was invented by John von Neumann.
Fetch, execute, decode. This is an animation. I think it's from Caboodle. Yeah, and this is a great animation for fetch, execute, and decode cycle.
Now what you just are seeing in this video is basically an example of how the von Neumann architecture. How does it work? So this video perfectly shows how the von Neumann architecture works. Okay. Now basically the von Neumann architecture contains of the control unit, the arithmetic logic unit, and registers. Now registers have the MAR, which stands for memory address register. MDR is memory data register. The PC is the program counter, and the ACC is the accumulator, and there is the CIR, meaning the current instruction register. Now the von Neumann architecture, or the FDE cycle / fetch, decode, execute cycle. So it's just a blueprint about how it functions. Now instructions are stored in memory and are retrieved and processed by the central processing unit, or in short CPU unit, one by one. Now this blueprint you are seeing is the von Neumann architecture. Now, the von Neumann architecture is basically from the fetch, decode, execute cycle. Now the process above is basically indefinitely. It will never stop. It's basically like it's indefinite, meaning fetch after it fetches and decodes, execute after it executes. It keeps repeating again and again and iterates. Okay. Now registers. Now what are registers? Okay, registers are high-speed storage areas in the CPU. All data must be stored in a register before it can be processed. So all data in a register that is inside the register stored has to be stored before it can be processed in the, we can say, high-speed storage areas in the CPU. Okay. Now here are some of the different registers and its function. Now the MAR, memory address register, holds the memory location of data that needs to be accessed. The MDR, memory data register, holds data that is being transferred to or from memory. The AC or ACC accumulator, where intermediate arithmetic and logic results are stored. Now the PC, aka program counter, contains the address of the next instruction to be executed. Now the CIR, the current instruction register, contains the current instruction during processing. Now there are some CPU components. Now the first one that carries data around the CPU is a data bus. Now regulates cycles per second is the clock speed. Instructs the other component is the control unit. And this control unit instructs all the other components. Now, what carries out the mathematical operations is the ALU, or for full form, arithmetic logic unit. Okay. Now, fast access memory locations in the CPU are registers, as you can see here. Now, the CPU composes of the control unit, arithmetic logic unit, registers, cache, buses, and clock. Now, all components work together to allow processing and system control. Main components of the central processing unit, including control unit, arithmetic logic unit, registers, cache, bus, and clock. Now, there are some factors that affect the CPU. Now, these factors are clock speed, cache size, and number of cores. Now the fetch, decode, execute cycle describes the basic operation of the modern computers, as I mentioned earlier. Now, each of the CPU components has a part to play. Now, main memory plays an important role as well. Now, this is the final part of the von Neumann architecture. The fetch part, the instructions are loaded into primary memory, RAM, before the processor starts running the program. Now, each instruction is fetched from memory in order and put into the appropriate registers. Decode. The binary representation of an instruction needs to be decoded before it can be run. Each processor will have slightly different encodings for instructions. Execute. Once the instruction is understood, the instruction will be executed, and the control unit will tell the other components what they need to do in order for the instruction to work. Now, here is the like you can say, the descriptive von Neumann architecture. Now I'll leave you to read this for 15 seconds. Okay, so I hope you read this. Now this gives you an understanding about how the von Neumann architecture works. Now, thank you very much. Thank you very much for seeing my lesson, and have a good day.